Controlling of lights and other home appliances are generally operated and maintained manually, but this may cause wastage of power due to carelessness of none other than us or unusual circumstances. To overcome this, we can use a very simple and effective electronic component known as LDR. So in this video, we will discuss about LDR, how it works, and a very basic circuit associated with it. So let's begin. The cadmium sulfide or light dependent resistor, whose resistance is inversely dependent on the amount of light falling on it, is known by many names including the photoresistor, photoconductor, photoconductive cell, or simply the photocell. When it comes to the construction, LDR uses an active semiconductor layer that is deposited on an insulating substrate like ceramic. The semiconductor is normally lightly doped to enable it to have the required level of conductivity. Then this snake-like track of cadmium sulfide, which is a light-sensitive material, is placed on the semiconductor. On the top and the bottom you can see the metal films which are connected to the terminal leads. It is designed in such a way as to provide maximum possible contact area with the two metal films. The structure is housed in a clear plastic or a resin case to provide free access to external light. Okay, so enough with the construction. Let us come to the working principle. In the absence of light, it is designed to have a high resistance, often known as the dark resistance, which lies in the range of mega ohms. When light falls on the sensor, the electrons in the valence band are eager to move to the conduction band, but it is not that easy to jump. It is only possible when the light intensity exceeds a certain frequency, and the electrons, on absorbing the photons, obtains the energy required to jump into the conduction band. This causes the free electrons or holes to conduct electricity and thus dropping the resistance dramatically. In daylight, it drops to 5 kilo ohms. Now it's time for the circuit. The resistor R1 controls the amount of current going through the LED. It's very simple to calculate. Here I'm using BC547, which is an NPN bipolar junction transistor. If you are using an LED with 2 volt voltage drop, you will have a 7 volt voltage drop over the resistor when the transistor is on, because you are applying a 9 volt across the terminal. Now on applying Ohm's law, you will get current is equal to 7 volt by 470 ohms, which is approximately 15 milliampere, and is usually a good current value for common LEDs. The variable resistor R2 is used to change the trigger point for the LED, that is, how much light that is needed for the LED to turn on and off. You can probably get away with a 10K potentiometer. It depends on the resistance of your LDR. But with a 100K potentiometer, you will have enough room for a wider range of LDR values. If we provide a power to the circuit and cover the LDR with a knob, then it is having a high resistance, and so less current is flowing through the circuit and the LED is turned on. On removing this cover, it has turned the LED off. So now you have understood how LDR works. You can very easily make some other cool circuits like alarm clock, simple fire alarm circuit, automatic emergency light, light intensity meters, transmitter receiver circuit for exchanging Morse code, etc. So I hope you guys have enjoyed this video. If you have, then don't forget to subscribe if you are new. It really helps us a lot. Also follow us on Facebook and Twitter for more updates. Be creative, be awesome. We are being ingenious. I will see you in another video. Until then, bye.